In this video, we're going to look at question 6. Use first principles to find the gradient function dy over dx for the curve y equals 5 over 3x plus 2. So effectively what we're going for is this dy over dx is simply we're going for a derivative, or we're going for the function that explains the gradient for this function here, y. So to begin with, I'm going to write out y equals 5 all over 3x plus 2. And then we need to have a second function for first principles that involves an h. So I'm going to create a new function and call it g. And g is defined as 5 over 3. Then every time we see an x in the function of y, for g we get x plus h. And that's plus 2, like so. So we've got our two functions, and now we want to see if we can derive a function that is the gradient for y here. So for that function, we're going to use the notation dy over dx. And what this means is the change in y with respect to the changes in x. And that can be defined as g take y all over h. Now I'm going to fiddle with this notation here, just so it's a little bit easier to follow. So one more thing I should put in is the limit, of course. Must always remember to put the limit. Alright, so as I mentioned, I'm going to fiddle with the form ever so slightly, such that we want h to come out the front, like so, and then we're going to get g take the function y. So what this will do, because our functions here and our functions here are fractions, what we want to do is we want to arrange it in such a way where it's just easier to see when we're doing our workings out. So that's why I brought this 1 over h out front. It will make more sense as we progress in the derivation here. So going on, I'm going to substitute the definition of functions g and h into this formula here, and that will give us an expression that will sort of explain the change in y with respect to the change in x. So we've got 1 over h times g, which is defined as 3x plus h plus 2. So that's all on the bottom, and upstairs is 5. And then away, or taking away from that, is y, which is 3x plus 2 all over, or all under 5. Alright, now I'm going to fiddle with this ever so slightly again, and these 5s here, I'm going to take them out because it's just simpler to have them away. So what's going to happen is the 5 is going to come out in front of the h, like so. I'm going to drop my limit down, like so. Highlight my 5 to show where it's come from. Then inside, we're going to get 3x plus h plus 2. That's all 1 over, and then the same over here. Alright, now we're in a position to start dealing with what's inside these parentheses here. So our objective is, effectively, is that we want to observe this expression here as h approaches 0, but if we put it in right now, what we'd find is that we'd go for a 0 there, and then we'd get an undefined result, and we can't have that. So effectively what we want to do is we want to deal with the h down here. And the way we're going to do that is we're going to somehow try and find that we've got an h up in the numerator, which will cancel out the h down in the denominator. So jumping into that, the way in which I'm going to try and achieve that is I'm going to try and cross multiply. So the denominator here and the numerator here, and then the denominator here with the numerator here. And that way I'll be able to express everything as a single fraction. So following that step. Alright, so I've managed to get everything as a single fraction. So notice that we've multiplied the two denominators together in the line just above, and then we've cross-multiplied the numerators and denominators. Now, our next step is we have to firstly break open everything that's happening in the numerator here. So we have to expand all of our terms, and then we have to collect like terms. And hopefully, if it all works out, what we'll find is that our 3x and our 2 will cancel out with our 3x and our 2 in the second term over here. So let's go ahead and try that. So this will become 3x plus 2, take away, and it will be 3x. So we're taking 3x, and then we're going to take 3h, then we're going to take 2. Alright, observing what we can see here, our 3x is going to cancel with this take 3x, and our plus 2 is going to cancel with this take 2. So effectively all we're left with in the numerator is our minus 3h right there. So writing that out. Perfect. So from this, what we can see is that we've got a single term expression inside the parentheses or here. And up in the numerator, it is minus 3h. So what I'm going to do is I'm going to highlight that h because it's going to be really important with what happens next. If we go back outside to the left of our parentheses and look at this factor here, notice that on the bottom it's h. So we've got 5 divided by h. If we multiply the outside factor into the fraction, what we find is that the h in the numerator and the h in the denominator are going to cancel one another out. And this is really good because it allows us to evaluate the limit or observe the value of h as it approaches 0 and then still maintain a feasible defined answer. So writing that out. Alright, and now I'm in a position to evaluate the value of h as it approaches 0. So we're going to go for the limit now. So although we're observing h as it approaches 0, every time we see an h in this expression now, we can replace the h with a value of 0 because h effectively becomes nothing. So evaluating that. And then taking care of evaluating the entire expression, so getting rid of the zeros, breaking all of these parentheses open, and multiplying everything out, collecting like terms, we're going to get, we've got a 3x plus 2 on the bottom times the 3x plus 2, and then upstairs we've got a minus 3 times a 5. Now simplifying all of this, 3x plus 2 times 3x plus 2 can be simplified down to 3x plus 2 all squared. Then upstairs we've got a negative 15. So this would be the y over dx. So the change in y with the change with respect to the change in x. And this would tell us the slope of y. So this is how we would find the gradient function of y, or the slope function of y, using first principles. So dy over dx equals negative 15 divided by 3x plus 2 squared.